come from New Brunswick, which is in Canada, not the one in the States. We have one too. I'm probably the first person, and I think I'm the person coming from academia. In fact, I don't have the name of the lab. It's Information Security Lab at the University of New Brunswick. We are, to some extent, a unique lab in the sense that we do a lot of R&D research. We work very closely with industry, local industry, and national in Canada. We also do research on the side, and this is something that I'm going to present today, something that is not affiliated with any NDA, so I can openly share with you. And because I only have 20 minutes, I'll kind of skim through, and if you have questions, we can talk offline, and kind of I can share some of the details that are not on the slides. All right, so the topic is actually Android malware, malware reuse. And probably the question that you might be asking yourself is, what does malware has to do with the software reuse? Software reuse is a very legitimate practice that is commonly used by software engineers. It has nothing to do with malware. And to some extent, you're correct. When it comes to the software use, it's very convenient. Usually have very tested, well-maintained pieces that have recognizable behavior, very recognizable look, the same feel. And this is something that seems to be very attractive to malware authors as well. This is the familiarity of the behavior and familiarity of the look seems to be abused in the malware. In fact, if you look at the numbers, you will see that probably most of the mobile malware that we've been seeing these days is attributed to the fact that it's being reused. And among the most targeted platforms is Android. Again, this should not come as a surprise to you, as most of the devices are Android platform. So mobile devices targeting Android platform. So that's what we see on the mobile malware domain as well. So what is a code reuse when it comes to mobile malware? Usually, when it refers to Android application, we're talking about repackaged applications. And simply because of the way the mobile malware works, usually the normal application, legitimate application is disassembled, added with additional malicious functionality, and then packed back. So that's why we're talking about the repackaged application. But in fact, the part that is being reused is a legitimate part. So that's how those two terms used interchangeably, so I'll touch on that a bit later. The fact that it comes with the legitimate portion definitely helps with the infection rate. We can see legitimate look, legitimate name, and more likely to download something that might have legitimate, suspicious functionality. So that boosts the infection rate, does help with the profit on the attacker side, obviously. So this gives you one example when you're talking about the code reuse or packaged application. The fill and functionalities, the normal functionality is still there with some additional pieces added, the payload added that can boost up the profit on the adversary side. So you might be familiar with this, but I thought to brought it up. The package itself, the Android application is a package itself that includes a couple of things. Among them is the set of resources that are meant to give you that look and feel. So we're talking about the image files, we're talking about the pictures, some of the sounds will be here. The digital certificate that basically is aimed to authenticate the author itself. Native code that might come as a binary. And might also carry additional functionality. The manifest file that will have some information about the packaging of things like permissions. And finally, the actual executable, the part that carries the functionality of the application. So when you're looking at these layers, each of these layers can be reused. You can see, we see the code reused at any of those layers. So you can basically take and replace and reuse the manifest file, or you can reuse all the resources that being in a legitimate application, so you can replace them. So all of these layers can see the code reuse. But what's interesting is that most of the time, they're being complemented with the reuse at the binary level. So I'm talking about the .dex file, which is an executable portion of Android malware. So this is something that we've been looking at more closely. And this is something that I want to talk about today. So the talk is about the myth and the reality of mobile malware. And looking at some of the, analyzing some of the recent apps, we realized that there are a lot of them. So here I'm just going to share our results on the three. The repackaged applications are malicious. The applications with ads are malicious. And finally, the meta and obfuscation is the sure sign of the malicious functionality. And I'm sure some of you are looking at this suspiciously. I know you probably see what the answer I have coming. So for this type of research, we looked at a number of different sources. Obviously, we look at the legitimate stream, which is Google Play Market. It claimed to be clean, but we thought we'll use it as one of the sources of information to perhaps disprove some of the myths for us. We looked at the f-droid, which is a new open source market for Android malware. It's unfortunately not that very large yet, but still we took it as one of the sources. We looked at six Chinese markets. This is the alternative markets for Android malware. There are different reports that claim different percentage of malware seen on those markets, some of them up to 50%. So we decided to take a range of them to see what kind of results we might get. So we have 6. The virus total stream and the Android malware dataset actually represents a number of sources. For those of you who are familiar with some of the benchmarks in academia is the Android malware genome dataset, Debian dataset, and the last dataset that we've used here is the botnet dataset that we received from one of the vendors, plus some of the botnet samples that we were able to find ourselves. So mobile Android malware dataset is just a pure malware that's being used in the past by a majority of the studies, plus we reconfirmed that in fact it does contain malware only and there are no additional pieces. So overall, we got over 60,000 applications, Android apps that we used for the study. Since I'm talking about the reuse, we set aside several categories that we thought are most likely to see the reuse, and you can see them here. Android system applications, this is basically SDK environment, the legitimate environment, and it includes all the libraries all the tools and libraries that come with SDK. The ad libraries, these are the most common libraries that we could find. The open source libraries, these are free libraries that can be reused for building the Android applications. App creators, you're probably aware there are a number of different tools in the market these days which can be used to help you build an Android application. So you don't have to go with the legitimate studio, Android studio. You can, for example, use a PhoneGap or some of their other tools to help you with the development. So we looked at app creators, all these various app generators and creators in this category. Commercial third-party libraries speaks for itself. These are all paid libraries that can be incorporated. The social network APIs, this becomes very popular with Facebook and Twitter APIs. Again, and we're looking at the categories that are meant to be reused. So this is something that you would expect to see commonly used in any legitimate application. Finally, the last 2 categories are something that we thought we might see in some of the malware samples. Android apps. If we're talking about the repackaged Android applications that reuse the code from some other application, then it's more likely that we'll see that code coming from some other application that is already on the market. So that's what this category stands for, Android apps. The code actually comes from somewhere else. And finally, code samples. There are a lot of different tutorials on the websites, on the internet, where you can just take certain code snippets and put them in your app and reuse them. So again, this is the code that is publicly available, built by someone else, and can be reused. So these are some of the categories that we thought can exhibit that code reuse that we're looking for. So now let's look at the myths that I mentioned. Repackaged apps are malicious. Here I want to pause and explain it a little bit. Because I come from academia, I have to read a lot of research. And in the past 2-3 years, the number of papers that came out proposing various types of detection methods for malicious Android apps just skyrocketed. Just 3 years back, if you did the Google search, you would find maybe 10, 20. These days, it's all in thousands. And obviously, there is a lot of research that specifically focuses on detection of repackaged applications. Now, interesting part of it is when that research talks about repackaging, they mostly mean code similarity. So from their perspective, looking at the code or at two applications that are similar essentially indicates that there is a repackaging. And since there is a repackaging, one application is supposed to be legitimate, another one is supposed to be malicious. So automatically, there is this connection between code similarity, repackaging, and maliciousness of applications. So it's a streamlined process. You go from code similarity immediately to malware. So that's why we wanted to look into that and see whether this actually makes sense to make this assumption. So we just, a brief overview of the apps that 60,000 apps that we've collected. You can see the 95% of the Google Play market seems to be reused, and this includes all those 7 categories that I mentioned before. So 95% is something that repeats itself. Common code is a code that we see more than 1% of our application. Record is just something that repeats itself more than twice, and obviously unique code is just something that you only see once. So ideally, if you think about this, if we were to do an analysis, even if we were to do this analysis on the code similarity, let's say we do want to compare that legitimate and malicious application and see and if there is any similarity, ideally you want to do that on only those 5%. You don't want to do it on the whole application, because if you do it on the whole application, that 95% will show you similarity. Probably not the similarity you're looking for. Now, f-droid, somewhat similar in percentages, and the malware collection, you see also 95% here. The 95% here in this particular comparison, we only looked at the similarity between the Google Play, the legitimate Google Play code and the malware collection. So basically, this 95% means that that code comes from is similar with what we see in applications found on the Google Play market. So again, just looking blindly at the similarity of the code between applications doesn't cut it. This is just for your information. If you want a little bit more breakdown, which of the categories are more prominent, well, obviously the Android system libraries, this is expected, right? This is the most common environment till date. So what's interesting is, though, the use of Android apps and the internet code. On the Google Play market, there's only 5% that is being reused from what we've seen before, meaning that borrowed from other applications or from some tutorials. You do see much higher percentage on malware samples. Again, which is expected. This is, if we're talking about malware that is being reused of families that sort of evolve and borrow certain code from one version to another version, we do expect that code to be similar. So 21% of that actually comes from some other applications, which again, something that we expected. All right, so let's look at the second myth. Apps that come with apps are malicious. And actually, there is a paper that specifically focuses just on analysis of apps as a sign of maliciousness. To some extent, we can see that that might be a sign of maliciousness depending on what type of apps and what type of ads you're looking at. But just in general, doing again a comparison between the legitimate apps and the apps seen in malware collection, you can see that the percentage is somewhat similar. So analyzing just the ads themselves and the amount of them and features that are not relevant to the content of the ads doesn't really give you much. You might find some similarity that might be an indication of something, but looking at it as a kind of the golden solution probably not gonna work. It has to be something smarter than that. Finally, I still have time for one more myth. Methods name obfuscation is a sign of malicious functionality. What I mean here is the common methods that have very familiar names, usually supposed to carry the same functionality. This is what you expect. So in malware, what we've been seeing is the replacement of the payload. So the method name stays the same, the payload is being replaced. Or the whole thing is actually being obfuscated. So you can't really do analysis based on that. You sort of don't even know what the method is. And some of the obfuscation tools have been doing that as well. The method names are being obfuscated, so you don't know what you're looking at. So we looked to see whether it makes sense from the perspective of malware detection. On the Google Play market, we've seen 91% or 41%, sorry, I'm mixing up the numbers today. 41% of the methods being obfuscated. So out of all common methods from the code that is being reused, 41 of that is being obfuscated. The percentage among malware collection is much smaller, it's only 12%. And again, I understand this is only statistics, pure statistics, but what I'm trying to emphasize here is that when we're building solutions and we're blindly looking at the assumptions like anything repackaged as malicious or anything with ads as malicious, this is just a too simplistic, too naive approach. It has to be something beyond that. So again, these numbers just emphasize that we can't blindly look at the method obfuscation as the feature for malware detection. So finally, what? So what? I gave you all these numbers, and my main point was to emphasize again the fact that we have to look for effective detection, we have to look for some clear alternative, we have to look for something smart. We can't just go with this traditional approaches that we've been dealing with so far. If it's similar, then this is bad. If it exhibits any of those signs, then it's bad. It has to be something that probably goes beyond this traditional approach. Something goes outside of the box. Or, as I recently found, instead of thinking outside of the box, just get rid of the box and come up with something that is going to be brand new, something that's going to be completely different, and will not rely on any of the assumptions that we had so far. Thank you so much. If you have any questions, I'm all yours.